up on the left-hand side. If you build them, in material cost, they're in between 500 and 1,000 euros, so it's more affordable. And what's most important, the printing costs are very small because they use a plastic wire that you can feed into an extruder. Unlike a glue pistol, those things, you get a thin line out and they melt this and you can shape your own object, and it's very cheap to make your objects. Okay, then the other way to produce your to realize your 3D object is by slicing. So I didn't do this in practice, but I want to show you a short animation of how you could do this. And I was looking for a willing subject, so I took Susanna. This is already a difficult and complex mesh if you want to slice this up. You have to look at how you are going to slice it up, because you're going to project this in 2D, make slices which you have to cut out some kind of material, and you have to put them together again. And to align all this, it's good to have a reference. So what you could do, and what often is done in this kind of steps, you're going to drill some holes in an axis perpendicular to the slices that you are going to make. And these holes are going to be a reference. So you do this in 3D also, in the virtual model you make. So you have two holes, which will be a reference. And then you can slice your object. And then you have to decide, okay, which layer do you use? Do you take the top level, or the bottom, or the middle? Anyway, you have to cut it out in some material, and to be able to put it back together again. So here you have your slices. For example, I just choose 11 slices of Susanna, and that would look like this. And you're going to cut this out, for example, with a laser cutter, and you see you go actually to 2D, from 3D to 2D. And then once you have your slices cut out, you're going to put them back together again. And there, the holes that you drilled in the shapes will help to align your slices again. And you will get something that will resemble Susanna again. But, of course, it depends how thin you take the slices, and it's not obvious to do this method. It's quite challenging, but it is a working method. And also what you have to look for is, I didn't point that out very well, but for example at the ears, you have some parts that are loosen now, and usually you cannot align them again. So if you're going to slice up your model, you have to take into account that you have loose objects, and you have to connect them first with a beam or a plane before you slice them, such that you can put them back together in the right position again. And then when you put it back together again, you have to remove the plane again. So it's a long method. It takes a lot of effort, but it is a nice method. And just to be sure, no animals were hurt. Susanna didn't feel anything, and she was happy when she was put together again. Then I will continue with press-fit construction. A press-fit construction is actually, you take a 2D design, you draw a shape, and you're going to fit it back again together. This is an example of a side table that I designed, and this is the principle of press fit. So you make some slots in your sheets, and you put them back together. You slide them over each other, or you click them together. You can make a box with slots like this, and you can fit them together. Very powerful method of making 3D projects of objects, But of course, this is not the standard way you would design something. You have a arbitrary 3D mesh, then you cannot really use this. And another method to realize your 3D models is by milling. I just have some simple pictures now, but you could use a CNC machine that is cutting out your shapes. And often that is done in 2 steps. You first do a roughing step where you see quite coarse steps, as you see in the right image. And then you go over the same object again, and you finish it, and it makes it more smooth. But the drawback of this method is that because you're working often, or at least in the FabLabs, with a 3-axis machine, you cannot have pockets in your design. So if you have holes below the surface you're milling, that's not possible. So you have to take into account your how you align, how you rotate your object, how you're going to process it, how you're going to route it. And another problem you have to face is that the routing path the tool is taking, the inside corner of your object will be a sharp corner, straight corner, but the outer corner will be round, and that's because of the diameter of the milling tool. And if you want to reproduce your model, you can make a mold. And the way to do this, you can use the previous methods, so 3D printing or milling, to make your mold, or you can make first your positive. So say this is your positive, this is the object you want to create. You can first create this by 3D printing or milling, and then you cast this object in a material, and you make your mold out of this. And then when you have your mold, you can create this same object again. This is a 3-step process. But you can also directly first create your negative, so the mold, and then create your positive by casting. And that's a 2-step method. Also, the same as with milling, the problem here is that if you want to take your object out, you cannot have holes or pockets, hidden pockets in your design. This should be easy to release, so you should adapt your design such that it can be taken out straight from your mold. I will tell you about 3 projects I did. The last 2 are more or less connected, but I will showcase what I've done. So first I will talk about a press-fit example of a side table. I call it Rose. It's standing here in front. So the object was to make a side table, and I wanted to use 10mm of acrylic sheet, and I wanted to use a laser cutter to produce it. I made the 3D design in Blender, but you could use any 2D software also if you want to draw it. But I also wanted to make a prototype of it in a model in Blender before I started to produce it. So here I was making the design. I used the photo layer as a background, and then I started to draft my design, and I scaled it a little bit because you cannot make the foot of the table. You cannot make it as thin as the stem of a rose. So I scaled it up, and I did what I thought was a good idea. And then, oh, go the wrong direction. You have to fill it up because I only draw the lines where I wanted to cut. So you fill it up, extrude it, and of course, then you can have a preview of how your table is going to look like. And once you're happy, you go back again to your 2D drawing, And then the nasty thing is, well, I didn't find it yet in 2.5, but I needed a DXF format to go to the machine to produce it. So I had to go back to 2.4.9, and there I could use the exporter script for DXF. I show it here in the screen print screens. What I use is the current 3D view, so I use just the top view or the side view, and then I use this in the exporter script, because then I know I'm perpendicular to the design and I don't have any lens or axis problems. And then it's quite easy. You just export the file and you have your DXF file, which you can use in the machine that is hooked up to the laser printer of the laser cutter. And often they use in the FabLabs, in one FabLab they use Illustrator, in the other FabLab they use CorelDRAW. In some other FabLabs I know they use Inkscape. So, but anyway, you can use your DXF file, import it. You have to check your scale, but if you design in millimeters or centimeters, or generally, you can say at the importation which measure you used, which unit you used. And then once you're satisfied, you print it. And I have just a short movie where you can see the laser cutter at work. Here you see the details of the head is going over the acrylic sheet, and sometimes it lights up where you see the plasma or the smoke is burning. Printing this whole table, so this table in the laser cutter, takes about 1 hour and 15 minutes on the laser cutter. This was a laser cutter of 6, do I say it? Yeah, I think 60 watts. So depending on the power of the machine, you can adjust the speed where the laser is traveling over your sheet. And that determines, together with the type of material, how quickly it is going. Let's see. I wanted to show you how the machine looks like. I don't know if you have a clue, but the movie is showing also the machine. It's about the size of this table, the machine. So it's like a big photocopier. Here it is. And you have smaller, you have bigger. But this is what they have in Utrecht, for example. Okay. Let's go to, no, not again. And this is how it looks like. But if you're interested, come and have a look at the table after the presentation. The other thing I did was a project for a wheelchair, an electric wheelchair. The idea was that we are going to use the tire that is on the wheelchair as a driver for some rubber tracks that would be mounted on the wheelchair. So this was a quite difficult project. We wanted to use the CNC mill to mill out a mold in chemical wood and then cast rubber into the mold. The whole design has been made in Blender, also this model of the tire. But the biggest challenge was to measure the real-life tire and to translate these measurements to Blender. I took a lot of pictures, and then you have the deviation of the angle of the camera and the lens, and you can measure it with a centimeter. But it's quite difficult to get it right. It took a lot of time to capture the design. So it would be very easy to have a 3D scanner or something. I know.
I'm currently making such a thing. Intended to bring it here, but I couldn't finish it for the conference. If I would have had 2 more weeks, I would have brought a 3D scanner
Okay, great. I like to talk to you with your 3D scanner, and it's great there's somebody in the audience that is also working with this. Come approach me afterwards. I'm interested. So to make the mold, I first modeled the tire just to see if it's looking right. Then I inversed the tire profile and make a print for the mold or for the external tracks in the inside, and I made invented an own profile for the tracks on the outside. That's on the left-hand side, bottom. And then I had to inverse all this again to make the mold. I made a mold existing of two parts, a bottom and a top part, and then you have to incorporate some pins and holes to align your mold parts such that they fit well, and you're sure that your object will be casted in the right offset. And what is also very important is that you realize which tool. So the milling tool, I was going to use the milling tool. How big is the diameter of your milling tool, and how long will it be? Because that determines how deep you can go. And since I had very small feature sizes, especially here in the profile, the distance here between these parts was about 2.5 millimeters. I needed a diameter of 1.5 millimeter, but this meant that the length of my tool was, well, I think I could go to 15 millimeters depth. So you have to really think about all these things when you're making your design. And this, for me, it was a lot of steps of iteration before I came to this design. And to test it, I made a smaller object, a smaller mold, only the bottom part, because that had the most smallest objects. And I did it to test it. And let's see, I have... Okay, what I did to do this, you can, if you have your 3D object, you can just export it as an STL file. That can be done in Blender 2.5 also. And this STL file can be imported in most other tools that are connected with routers. So I use two different toolpaths. There's one CNC mill in Utrecht, and they use Desproto to calculate the toolpath. The toolpath is how the tool is going to travel over and in your object that you're going to mill. And then you need a second program. In this case, it was NC Studio. That is the real-time controller to the tool. So that will say go to the left, to the right, and which speed, etc. In Amsterdam, they use a different software. They have a ShopBot, so they have the ShopBot software there. So to show you a little bit, this is not the mold for the tracks, but this is a different mold, how the milling tool is working. The mold that I'm making here is for some silicon plugs. I have it here also with me, so if you're interested, you can come and have a look after the talk. And this is going quite good. The chemical wood is a sort of a plastic, and it gets a very fine structure. It's a little bit like wood, but it is has a more fine structure. And this is a different router. At Amsterdam, this is the ShopBot. And here are the results after the first pass, the roughing of the. This is the mold for the tracks. As you see here, it's quite coarse still. But if you do the second step, then you really recognize what you want to have, and you get a very nice structure. And this I used to cast plastic to validate if the mold was working and if it would be fitting. So as explained before, I used the two-step method. instead of the 3-step casting and molding method. And again, you can use the different methods that I explained already. Okay, yeah. This was a very funny moment. I was using a plastic to cast, and this was a very quick curing plastic. So while I was pouring the plastic in the mold, it already got stiffened, and I had the cup inside my head, but I could loosen it. It was suspended over the mold. But luckily, most of the mold was filled, and we could validate that it was working. And this is the result of the hard work. And we fitted it on the tire. It was fitting perfectly. So this is a valid method to really to realize your design. Let's see. Why is it not going? Oh, okay. So I want to share some tips how I learned to work with this. Was basically first by this document I found on the internet from Robert Burke about precision modeling. It's maybe a cumbersome method if you're used to CAD drafting in commercial packets. I mean, this is very difficult method, but you can reach your objective if you want to. There's an add-on now available. It's called CAD Tools, which will make a lot of functionality available. But I used just the simple Blender tools like grab and extrude and snap. Another thing you have to take into account when you realize your design in Blender is that you have to also take into account which units you're going to use. How big is your design going to be? I generally work with millimeter unit, and until now, exporting to DXF and STL, no problem. He often, if you import your STL or your DXF in another software tool, he is going to ask you which unit you're going to use, so no problem. And then to measure lengths in Blender, I used often in the edit mode the edge length tool. It's not the nicest way to see which lengths you have, but it's a nice way to do it. And then I use the snapping, the extruding, snapping to the cursor and things like that. Very basic Blender methods. Okay, I'm nearly finished. These are some other designs I wanted to share with you. I made some shelves also in acrylic sheet and plexiglass. The left is the model I made in the render I made in Blender before I realized my design. And the right hand side you see the picture of how it has become. The stands, the vertical stands, are made of 20mm thick acrylic sheet, and the shelves are made of 10mm thick acrylic. And the shelves I cut out with a laser cutter. They have a sort of a wave shape in the front of the shelves, and which is going in the inverse direction on the layer above the other shelves. So there's a sort of a wave pattern in the shelves. And then the shelves are fit into the stands by slots that I milled in the 2mm thick acrylic sheet. So these are some more pictures of the shelves. And this is the last slide, well, almost the first last slide, where you see the mold that I also showed you in the video that I was milling out. For some other design, I needed some specific element, a siliconic rubber plug just to protect some glass shelves that I was going to use in the design. And well, if it's not available, why don't make it yourself? So I just draw a shape in Blender that I thought was useful for my design, which would fit into a tube. And then I made this mold, milled it out, cast the rubber into it, and voila, it's so easy if you have a FabLab available. So with this, I want to thank you for your attention. More information about the FabLabs can be found on these links. The MIT link is to the original website from the MIT where the FabLab is introduced. If you're interested in this design of the side table, I entered a competition, a limited design contest, and I entered this design. So you can find it, and if you want, you can go to your own FabLab in the neighborhood or make a duplicate of it. You can find the design on the first link. And if you want to contact me, my email address is there also. Thank you for your attention.
Thank you, Michiel. So, a quick break before we continue with Nelson. I think, Ton, do you want to tell about the moved developer meeting? Shall I mention? So, okay, the developer meeting we normally have on IRC normally starts at 4? 4? Yeah? Oh, 5 in Finland, because I'm from Finland. So, a half an hour later it will start. So, people in IRC who are waiting right now, be patient.
Hello?
Hello. Okay. So let's continue with Nelson Goncalves and research for Blender, the learning experiences in the network. Please.
Thank you. There's a good thing and a disadvantage about talking late Sunday. I guess the advantage is that this has been an amazing conference. So many talented people, so many nice people to meet. So this is probably my first Blender conference, but I hope it will be the first of many to come. The disadvantage is that I couldn't drink all the beer that I wanted last night in the dinner, so it's not that great. Anyway, I wanted to start with this picture. I want you to try to picture a planet outside in outer space. It's called Planet Blender, where we all are living in there. Most of you probably are picturing a kind of a cube. I could have molded a cube. It's not that difficult in Blender to set up a cube. But after reading Thomas Friedman's The World is Flat book, I decided to choose this image. Now, in this plane, in this planet called Blender, we are all in this planet living among different tribes. Some of you guys decided to live in the forest with the elves of the character animation. Some of you decided to live in the mines with the dwarfs of sculpting. And others are learning the dark magic of Python and join the order of the wizards, aka the developers. What I'm interested in is how do you guys learn Blender in your daily life. So a little bit about myself. Blender came quite naturally for me because it's in the intersection of 3 dimensions of my person. I love animation since I was a very young boy. My first trial with animation, I was around 5 years old, I guess. And I tried to draw Mickey Mouse in a film. It's called direct animation, drawn film. And I couldn't get Mickey Mouse there, so I get a little bit frustrated about it. And some years ago, I found out that probably it was already Norman McLaren trying to influence my animation with the dots. I'm also a free software user. I believe and I respect and I identify myself with the values and the core principles of free software. So I only use free software in my daily life, for professionally and personally. And I also am a teacher, full-time teacher. So Blender came out quite naturally when I pick up these 3 very important things in my life and I put them together. As a teacher, in the last few years, I've been trying to use free software wherever I can. At the top left, you have 2 pictures from a kindergarten school. I teach in teacher training programs, mostly. So some of my students are future kindergarten teachers. And I managed to get my paint and some tablets and some interactive boards in schools. So probably, maybe, we are seeing some future David Rivoy wannabes over there, drawing for the first time with my paint. On the right side, you're seeing a kid from also a kindergarten recording a podcast. Actually, he's using Audacity, probably you guys know the program, to record his story, and then I helped him to put the story in a movie with Blender Video Sequencer with some pictures that he also draw. On the bottom side, on the left bottom side, there's a picture of a workshop at my school. I work in a college of education, and those are some students, 10 students there, and Ricardo Ramalho is a friend of mine. He's a Blenderhead, a Portuguese Blenderhead, and he went there for a couple of workshops. I don't know if there are many teachers in the audience, but I'm really proud of that image because it was a Saturday morning. There are no classes on Saturday, and I managed to get 10 students Saturday morning at school working because of Blender, so I felt really proud. And on the right side, it's Open Lab. It started 1 year ago. It's also a project at my school. We have 6 computers there. We only are using free software, so it's GNU Linux systems and all kinds of stuff. We are using Inkscape, GIMP, Ardour, Audacity, etc. Processing, pure data, etc. And Blender plays a major role in this. Now you can see that most of my work with students, I like this picture because it kind of shows it off. Most of my work with my students is like this. I'm the guy sitting there with the beer and the long hair. So why I'm here and what am I looking for with this project? This is my PhD project. And I'm interested in what the Blenderhead culture is, what the Blenderhead community works, how it works, how people are doing to learn Blender. I don't know if you guys are noobs like me or pros, but either way, you have learned and probably you are still learning how to use Blender. And most of you probably are learning Blender outside formal settings, outside the schools. So we are using informal and non-formal strategies to learn Blender, and I'm mostly interested in that. I'm also interested in using Blender in a formal setting. I have some background on that, but I'm mostly interested in informal and non-formal strategies. So basically, I'm studying the culture of Blenderheads, and I want to produce a detailed description of how people learn Blender. Because this is a PhD project, I need a theoretical framework, and